Let's take a look at a normal approximation to the binomial distribution. We have a binomial distribution that has a large amount of it's actually been shown as the normal distribution, and the normal distribution is a little bit easier to work with. You can see a picture of why this happens on page 365. You can see those histograms for a binomial distribution and how they're making that very nice normal shape, and that's a great way to make dealing with mathematics easier. 1,000, sorry I left out a zero there, households, and find 734 have cable. That means she surveyed 1,000 households, or was 1,000, and there's a 70% chance that she finds somebody who has cable, or P is 0.7. So how do we go ahead and find the normal approximation? What we want to do is first find the mean and the standard deviation. This is something we talked about much earlier when we talked about the binomial distribution. To find the mean, we multiply n times p, or 1,000 times 0.7 is 700. To find the standard deviation, we multiply n times p, 0.7, times 1 minus p. 1 minus 0.7 is 0.3, and take the square root. So let's say 1,000 times 0.7 times 0.3 is 210, and we'll go ahead and take the square root. And what I get is about 14.491. We'll call it 14.49. So we have the mean, mu, and the standard deviation, sigma. And then I want to find our x value. And finding the x value is interesting. You can see a nice visual representation of this on page 365, and why we do this. It has to do with the histogram and why the divisions happen. But what we do is we say, okay, if we want to find a probability of less than, we bump our x value up by 0.5. If we want to find a probability of greater than, or at least, we bump it down 0.5. Okay? Let's get my spelling right here. Geez. There we go. All right. So we have 734 as our x value, or what we're interested in. Now, I'm going to try in my question to find the probability of finding at least or 734 or greater than. And in order to make this approximation more accurate, what we're going to do is we're going to use an x value. We're going to bump it down by 0.5. Remember, less than, bump up, greater than, bump down. It makes our things much more accurate. 733.5. So I want to find the z-score. 733.5, my x value, minus my mean that I found from before, divided by my standard deviation, which was 14.49. So I'm going to go ahead and subtract 733.5 minus 700 and divide by 14.449. What I got was 2.31. I'm rounding off my calculator wrong, sorry. Let's round correctly off the calculator. 2.31. Now I'm going to go over to my standard normal table and find the value for 2.31. 2.31 gives me a probability of 0.9896. Now remember, This is full of things you got to remember. The key word was at least or greater than. The normal table tells us at most or less than. So we have to subtract from 1. So I have about a 1% chance of finding 734 households or more with cable. So this is telling me that I have about a 1% chance of finding that. So that means that 734 households will have cable or more if the true proportion is 0.7. So it's kind of a dichotomy here. We're saying that it's 70%, but then we're saying that it's greater than 70. Okay?